What is intergranular corrosion, and why does it break metals? Imagine a metal structure that looks perfectly fine on the outside but is secretly weakening from within. That's what intergranular corrosion can do. It is a type of localized corrosion that targets the edges where tiny crystals in metals meet, called grain boundaries. These boundaries are like the seams between puzzle pieces. Metals are made up of many small crystals, and these boundaries can become different from the rest of the metal due to chemical changes. When this happens, the boundaries become more vulnerable to corrosion. The process begins because these grain boundaries can act like tiny electrical circuits. They become anodic, meaning they are more prone to losing electrons and dissolving. Meanwhile, the main part of the metal acts as the cathode, or the part that stays intact. This difference creates a small galvanic cell that causes the boundaries to dissolve faster than the rest of the metal. Over time, this attack weakens the internal structure without necessarily changing how the surface looks. Intergranular corrosion often happens because of specific metallurgical conditions. For example, when certain alloys like stainless steel are heated or welded improperly, carbides can form along the grain boundaries. These carbides are tiny particles that deplete important elements like chromium from nearby areas. Chromium is what makes stainless steel resistant to rust and corrosion. When chromium is lost, those areas become more prone to rusting. Another cause is the segregation of impurities or alloying elements at the grain boundaries. These zones with concentrated impurities are less resistant to corrosion. Improper heat treatment can also cause a process called sensitization, where carbides form along the boundaries and deplete the metal's protective elements. This makes the metal weaker and more likely to break down from corrosion. The damage from intergranular corrosion can be serious. It causes the grains to lose cohesion, making them detach or fall out. This reduces the metal's strength and ductility, which means it can't bend or handle stress as well. Even if the surface looks fine, the inside can be severely compromised. This hidden damage can lead to sudden failures in pressure vessels, pipelines, or structural parts. Preventing this type of corrosion involves controlling the composition of the alloy. Using low-carbon or stabilized stainless steels helps prevent carbide formation. Proper heat treatments can also reduce sensitization. Applying protective coatings or surface treatments can shield the metal from environmental factors that cause corrosion. Understanding how intergranular corrosion works helps engineers and technicians diagnose failures and choose better materials and treatments. It shows how tiny changes at the microscopic level can cause big problems in the real world. Recognizing these signs early can save time, money, and even lives by avoiding catastrophic metal failures.